Okay, good day to everyone and the viewers who watching this presentation. We're here to present two topics, the geothermal power plant and the hydroelectric power plant, to be presented by John Christopher C. Gallardo, Russell Jake Perido, and Pauline Yambot. We begin this presentation start with the discussion of geothermal power plant. Next. Okay. Definition of geothermal power plant. Geothermal power plant are used in order to generate electricity by the use of geothermal energy, the Earth's internal thermal energy. They essentially work the same as a coal, solar thermal, or nuclear power plant, the main difference being the heat source. Next. Okay. The working principle of the geothermal power plant. First, there are natural resources deep within the ground, somewhere around 2 to 3 kilometers below. Well, when we dig on this ground, we can see a pool of water heated by a magma. They're harnessing it on the geothermal power plant and powering up the turbine connected to the generator to generate electricity. Well, this is the principle of a geothermal power plant. We use the steam on the below the ground 2 to 3 kilometers, and this steam uh, power up the turbine and the generator. Well, this there are a good question on this. Where we can build a geothermal power plant if our reservoir is the heated pool of water. Well, this answer we can see on it on the next slide. Okay, ranking of largest geothermal plants worldwide as of January 2021. Well, the Philippines is ranked 40th in these geothermal plants. Well, the name of geothermal plant is Macban, Philippines, that located on Laguna. The biggest geothermal power plant is the geysers that located on United States. Second is Larderello from Italy. The third one is Cerro Prieto from Mexico, and the fourth is the Macban from Philippines. Next. Top 10 geothermal countries 2021. Well, the Philippines is still on the rank. We are on third place when it comes of summation of total product of all geothermal power plant here on the Philippines. Well, the first is US because of the geysers, and because of this is the biggest geothermal power plant. Then the second one is the Indonesia. Next. This is the picture of Macban Geothermal Power Plant located on Laguna, Philippines. Next pic. This is the picture of the geysers, the biggest geothermal power plant located on United States. Next. Ideal location for geothermal power plant. Well, along sa mga ideal location, usually found along major tectonic plate boundaries where most volcanoes are located. One of the most active geothermal areas in the world is called the Ring of Fire, which encircles the Pacific Ocean. Ngayon, yung ating bansa is kasama sa Ring of Fire. Kaya yung ating bansa, pwede tayo magtayo ng madaming geothermal power plant dito kasi ang ating bansa is nasa Ring of Fire. Okay, skip tayo sa ibang sasabihin. O sa baba tayo. Geothermal energy finds its way to the Earth's surface in three ways. Ngayon, sa three ways na to, ito yung volcanoes and fumaroles, or holes in the earth where volcanic gases are released. Then lastly is the hot springs geysers. Ang hot spring, yung mga geysers pala, ito yung fumaroles, hindi. Yung fumaroles pala, yung para siyang fountain. Tapos yung geysers yung parang hot spring. Next. This is the picture of ideal location. Ito yung sinasabi ko na hot spring siya na pwedeng pagtayuan ng geothermal power plant. Kasi yung hot spring po ay nanggagaling din sa ilalim ng lupa. Next. The working principle of dry steam power plant. Dry steam power plant is the first type of geothermal power plant. Bali, meron pala tayong tatlong types of geothermal power plant. Ito ang una, yung dry steam power plant. Working principle please to the schematic diagram of this dry steam power plant para maano natin. Next pa. Yan. This is the schematic of dry steam power plant. Working principle in it. The first we have to extract the steam on the water, on the pool of water heated by the magma. And this steam travel to the tube with 2 to 3 kilometers long. When the steam comes up or when the steam travels on the tube are already connected on the turbine. And the steam are ngayon yung steam naman, siya yung magpa-power up doon sa the turbine are connected to generator. When the turbine power up the generator will start and convert the mechanical energy to electricity and connected in step-up transformer. Yun lang siya para sa paggawa ng electricity. Well, the excess of steams are flow on the condensers and going back to the ground. And this is the cycle of dry steam power plant. Sa makikita nyo sa picture na yon, di ba, kumuha nga ng steam, pupunta dun sa tube and connected the turbine. Then and this system, siya yung magpa-power up doon sa turbine, siya magpapaikot sa turbine, and this turbine connected on the generator, and then the generator will start and then convert the mechanical energy of a turbine into electricity. Ngayon, yung excess na steam na natira doon, yung excess steam, mapupunta siya sa condensers. Then the condenser will which the steam becomes a water, then going to the ground. This is a cycle of dry steam power plant. And this is the working principle of it. This is a very simple cycle of geothermal power plant. Next.
So ituloy na natin dun sa second type ng geothermal power plant, which is yung flash steam power plant. So ito din yung working ng diagram. Yung kaibahan naman nito dun sa may naunang type ng power plant is yung gamit dito is water. Parang yung mainit na hot water from underground is pumped into a colder temperature. So yung mainit na tubig na yon, magpo-produce siya ng steam na magpapaikot dito sa turbine. Tapos nakakonect din to sa generator na magpo-produce na ng electricity. So yung mga steam na hindi kasi lahat ng steam is papasok dito sa generator, ay hindi magagamit dito sa pag-ikot ng turbine. So babalik din ulit siya doon sa may tubig underground. So ganun lang siya. Pero yung parang yung process niya same lang, different lang sila ng types na ginamit. So next, eto ngayon. Tapos dito, may brine or yung salt water. Yun yung ginagamit. Yung galing nga sa tubig sa ilalim. So, galing dito sa ilalim, yung tubig aakyat dito. Tapos yung steam, aakyat sa dito. So, hindi naman lahat ng water na yun is mapupunta dito sa paakyat sa turbine. So, yung waste brine, dito yung mapupunta naman sa bababa ulit siya. Cycle ulit, balik ulit sila dun sa baba. Tapos yung yung namang umakyat na steam, paikutin yung turbine. Tapos punta na ulit dito sa generator para ng electricity. Mag-convert ng mechanical energy to electrical. So, yan lang din siya. Next naman is yung binary cycle power plant. Sa binary cycle naman, sayang mo natin. So the main difference is that the water or steam from below the earth never comes in direct contact with the turbines. Instead, water from geothermal reservoirs is pumped through a heat exchanger. So yung heat exchanger na yan dito, aakyat dito yung tubig, parang magkapapalitan sila. Etong tubig na umakyat dito kasi 'di ba mainit 'yon. Papainitin niya yung fluid na nandito para magka-produce ng steam para mapaikot yung turbine. Tapos yung second liquid is heated into steam, yun nga yung sinabi ko kanina, na nagpapaikot dun sa turbine. Hot water from the earth is recycled into the earth through the injection well. Parang yung sa dalawang naunang types, may sa injection well, dun yung parang nare-release or yung nag-exit yung mga hindi nagagamit na fluid. So, panoorin natin tong video na isa.
Geothermal energy gives us a steady supply of electrical power with minimal environmental impact. Here is the basic process. Water in underground reservoirs is heated to high temperatures by magma. Production wells drilled up to 10,000 feet below the Earth's surface tap into this hot fluid. Under its own pressure, the fluid flows through these wells toward the surface. As it travels, the pressure lessens, causing a small amount to become steam. Together, the hot fluid and steam move through a surface pipeline to a wellhead separator, where the pressure is reduced. Here, most of the fluid vaporizes and flashes into high-pressure steam. Any fluid not flashed into steam moves to a standard pressure crystallizer to produce standard pressure steam. Remaining fluid is then flashed at a lower pressure to create low-pressure steam. All steam created in the plant is sent to a turbine on site. The force of the steam spins the turbine's blades, which turns a shaft connected to an electrical generator. An electrical charge is created and directed to a transformer, where the voltage is increased and sent down power lines. Any fluids not flashed into steam return to the underground reservoir, where, in time, they will be reheated and reused. Geothermal energy, a simple, clean, and renewable energy source.
So, yun yung mas explanation. Balik tayo dun sa PowerPoint. So, next naman is yung construction cost. So, medyo mataas daw or mahal yung paggawa ng geothermal power plants. Pero yung operational cost soon become relatively low kasi nga galing siya sa natural resources. This means that even though geothermal energy becomes financially worthwhile in the end, the cost of power plant construction may put geothermal energy out of the question. So kahit nga mahal yung pagpapagawa, magiging worth it naman kasi mahal yung bayad din na makukuha mo sa after mong yung electricity. Next, move on na ulit tayo. So next is yung advantages naman ng geothermal power plant. Includes daw dito sustainability and consistency. Geothermal energy is renewable, so it's both more environmentally friendly and less susceptible to natural resource wars than fossil fuels are. Geothermal can consistently produce energy output 24/7 regardless of weather conditions or seasonal changes. Kasi nga galing siya sa underground na which is mainit kahit mag-iba yung climate dito sa atin. Hindi siya masyadong naapektuhan kasi malalim yung pinagkukuhanan. So in disadvantages naman are geographic limitations and high cost associated with power plant constructions. This need to be built over regions with underground reservoirs or hot stream or water. Yung sinabi nga kanina ni Christopher na yung may mga hindi lahat ng lugar is pwedeng magkaroon ng geothermal power plant. Meron mga limitations. So yun na yung end nung first topic. So next is the hydroelectric power plant or hydropower. So yung working principle niya is capture the energy of falling waters to generate electricity. A turbine converts the kinetic energy of falling water into mechanical energy. Then a generator converts the mechanical energy from the turbine into electrical energy. So yung mga falling water naman to, kanina yung galing siya sa underground water. So here are the largest hydroelectric power plants. So yung first is Georges Dam sa China. Next is sa may Itaipu Dam naman sa Paraguay, Brazil. Next is sa China ulit, name niya is Silaudu. Tapos Brazil, Belomonte. The next one is Guri sa Valenzuela. Tucuri in Brazil. Grand Sauli sa United States. Xianggiaba in China. Tapos Longtan Dam, China. Tapos Saya no Shushenkaya sa Russia. So makikita natin na ilan doon sa pinakamalalaking hydroelectric power plant is located sa China and Brazil. So next. So ito naman yung largest hydropower in the Philippines. Ito yung Magat Dam. So yung Magat Dam daw has a maximum output of 38 megawatts lang. Compare natin dito sa mga capacity nung mga nasa largest natin around the world. So nag-start yung construction niya 1975, tapos nakompleto siya in 1982. Tapos yung dam na to is almost lahat ng dam naman is a multi-purpose dam. Hindi lang siya para dun sa pag-produce ng electricity, pero irrigation din siya. So located siya sa Namilangan, Alfonso, Lista, Ifugao, and Ramon, Isabela. So, Iligan Combined Cycle Power Plant and Dual Power Plant is the largest in Philippines with a generating capacity of 1,200 megawatts. Luzon Grid has a total of 14,340 megawatts. So, 3 Georges Dam in China sa capacity of 22,500. So kahit yung buong Luzon Grid, hindi pa rin niya kayang tapatan yung napoproduce na capacity nung sa China. So how it operates. Ito yung parang mga parts ng hydropower plants. The first one is dam.
And okay, how it operates. Yung mga parts na ito. Dam. First, the dam. Most hydropower plants rely on a dam that holds back water, creating a large reservoir. Often, this reservoir is used as recreational lake, such as a Lake Roosevelt as the Grand Coulee Dam in the Washington State. Intake gates on the dam open and gravity pulls that the water through the penstock of a pipeline that leads to the turbine. Water builds a pressure as it flows through this pipe. Turbine, the water strikes and turns the large blades of a turbine, which is attached to a generator above it by way of a shaft. Generators, as the turbine blades turn so as a series of magnetics inside the generator. A giant magnets rotate past copper coils, producing alternating current or AC by moving electrons. You'll learn more about the generator works later. Sa another, i-discuss na natin yan mamaya. Next. How it operates. Next, the transformer. The transformer inside the powerhouse takes the AC and converts it to higher voltage current. Power lines out of every power plant comes our wires, the three phases of power being produced simultaneously plus a neutral or ground common to all three. Read how power distribution grids work to learn more about power lines and transmission. Outflow. Used water is carried through pipelines called tail traces and then renders the river downstream. Okay, next. Mas maganda yung isang kwan. Pero ito yung isang kanya. Yan. Ayan na nga. First natin, papansinin natin yung pag-elevate niya. Yun yung pinaka-importante sa atin yung pag-elevate, yung elevation ng dam, yung paano itatayo. And then, makita mo, mas malakas ng persa ng agos ng tubig. Yan. And then, ang concrete barrier naman ay hinahadlangan ng agos ng tubig from the reservoir. Makikita mo yung reservoir natin dyan. And then, from the outflow, makita yung outflow dyan. Yung outflow. Kapag kailangan na ng electricity, bubuksan yung gate. Meron yung makikita yung gate dyan. And then, kapag bubuksan yung gate, yan na yung umiikot kapag umiikot ng turbine. Kapag umiikot ng turbine, connected na sa generator, iikot ang armature mag-generate ng power. And then, pupunta na sa step-up transformer. At doon na pupunta sa substation na. Yan o. Substation na. At yung mga substation naman, dadalhin sa mga power utility. Sa power utility. At yung mga power utility naman, i-distribute sa mga consumer. Ang purpose naman ng draft tube. Makita dyan yung draft tube. Yung draft tube. Yan yung nasa baba. Mas palakasin ang ikot ng turbine. Kasi, ang spillway naman ay kapag critical ng level, ang spillway. May spillway. Meron kang spillway dyan. Yan. Kapag critical na ang level, kapag na yun na yung critical na level, doon na magpapakawala ng tubig. Yun na. Yung fish ladder, meron kang makikitang fish ladder dyan. Ito naman yung minimize impact ng mga marine ecosystem. Yun yung mga ginagawa. Next. Right, okay na yan.
Supply of water and an elevation to drop it. Building a dam creates a reservoir which stores water until it's used. Water enters the generating system through a series of giant intake pipes, then travels down a steep pipe called a penstock, creating a massive column of water with a huge amount of force. At the base of the penstock, the water passes through the turbine. The giant blades rotate the drive shaft in the turbine, which is connected to a large generator. This converts the mechanical energy into electricity. The electricity travels along high voltage wires to transformers, then onto transmission towers, where it connects into the provincial power. After passing through the turbine, the water continues through the tail race where it rejoins the river below. A hydroelectric dam is a remarkably simple, sustainable, and clean way to generate huge amounts of power.
In about of construction of hydropower plants. The construction of this dam is difficult and labor intensive. Before construction begins, water is diverted and prevented from moving to the construction site. After a water is diverted, the foundation area is cleaned, excavated, and rock or sediments what will act as the foundation as repaired and deemed solid. This is done to ensure the rock of sediments won't shift or fail as a result of the load of a dam and reservoir. Support known as a rock bolts may be used to strengthen and form the foundation. Above the dam, rock bolts and netting may be used to prevent rocks from falling on the dam. Forms are built along the edge of the dam. Rebar is placed inside and concrete is pumped in. This is done in sections. Is the concrete is poured bit by bit in a block formation. Once enough of the dam is built, the reservoir is allowed to fill a highly controlled manner. The dam is monitored during this process. Other structures that make the dam operation and the then added. Ito yung mga sinasabi. Ang pag-construct ng dam, syempre, matatagalan tayo yan. Syempre, hindi yan bira ng bira. Magse-survey. Ang unang mag-i-step dyan ay magse-survey sila yan. Kung ano yung mga importante. Kagaya ng volume ng tubig at yung bilis ng agos ng tubig, kung paanong araw, ano yung date, ano yung buwan, kung ano yung pinakamalakas dyan. Kaya, hindi sila basta bira ng bira yan. Aabot ng 1 taon, sigurado yan. And then yung labor intensive naman. Talagang hindi basta-basta to. Ida-divert talaga yung agos ng tubig. Paghihiwalay niyan. Iplano yan ng mga mason. Kaya may mga mason, engineer na magplano diyan. And then madami pang pera na magagastos diyan. Madaming cost. Kaya hindi basta-basta nagagawa yan ng dam. Kaya yun, pinagplaplanuhan talaga. Kung saan maganda, kung saan yung mas malaking pagkunan ng mga tao, yung pagkaperahan magagamit. Next. Ito naman yung mga iba't ibang design ng dam. Yung solid gravity dam, yung una. Ito yung mga common na dam na nakikita natin yan, no? Ganyan. Arch dam. Ito naman yung pagkaiba na yung position niya. Makikita man na natin yung mga pinagkakaiba na ng position, kung ano yung mga mas nakadepende diyan sa mga engineer kung ano yung gusto na. Pero yung pinaka-common talaga yung solid gravity dam. And then yung buttress dam. Yan yung sige, next. Ganyan din yung okay, ito na ang pinagkakanan natin. main factors that determines the dam power output. Okay, next. Makikita natin yung next yan. Yan. Hydroelectric power plant ay hydropower. Ito yung niya. Two main factors niya. The amount of electricity of a hydropower plant produced depends on the two factors. How far the water falls. The farther the water falls, the more power it has. Generally, the distance that the water falls depends on the size of the dam. The higher the dam, the farther the water falls, and the more power it has. Scientists would say that the power of falling water is directly proportional to the distance it falls. In other words, water falling twice as as much as energy. Ito yung sinasabi dito, yung kapag mas mataas ang impact ng turbine, more generating electricity. Siyempre, alam nga naman, doon talaga ang pupuntahan niyan kapag the amount of electricity for waterfall. We need a proper amount of volume. Talaga naman. Yan yung, siyempre, kapag napakalit naman yung volume, magkakamatch ka rin yung papasok sa generator. Siyempre, proper amount ng volume yung pagpagsak ng tubig. Amount of water falling. Next. More water falling through the turbine will produce more power. The amount of water available depends on the amount of water flowing down the river. Bigger rivers have more flowing water and can be produced more power, more energy. Power is also directly proportional to river flow. A river with twice the amount of flowing water as another river can produce twice as much energy. Yan lang naman ito naman yung dami ng tubig niyan. Yung amount of water falling. Next. Yan. Meron naman na nakikita yung tallest dam. Eh, syempre. May malawak, may tallest. Yung pangataas. Mataas and makon. First, the tallest dam is Nurik Dam on the Vanjagas River in the Tajikistan. It is at 984 feet or 300 meters tall. The Hoover Dam is at 726.4 feet or 221.3 meters tall. Today, Hoover Dam is still ranked in the top 20 of the tallest dams in the world, but only in the concrete gravity and arch categories. Yan. Makikita naman natin, ma-imagine naman natin kung gaano yung mga 300 meters kung nakikita na natin yung mga poste-poste sa amin dito kasi every post 100 meters yan. Depende na sa inyo kung paano kayo estimate ng 300 meters. Alam nyo naman na kung gaano kataas. Ganun yung kataas nyo kapag. Okay, next. Dam failures. Banjiao Dam, Henan, China. 1975, Banjiao Dam is a failure of 26,000 dead from flooding. 145,000 dead from subsequent famine and epidemics. 11 million of homeless cause of generation. Dam failed by overtopping in 2,000 years flood. Ito ay nangyari ng 1975. In Machuchu, India. Yan yung pangalawa. And then, yung pinaka-latest, yung Oroville Dam, California, in United States. Damage spillway cause of explication of 180,000 in 2017. Ito naman yung catastrophic. Ito yung nangyayari, catastrophic failures yan. Talagang hindi yan maiiwasan. Merong pagka-failures talaga sa atin. Hindi naman tayo perfecto. Pero, ibibihira yan sa atin. Yun lang. Next. Yun na yung pagtatapos. Goodbye, sir.